Number 15 says the area of a circle is increasing at a rate of 3 centimeters per minute. Find the changes of the rate of the area. Okay, so area we know is pi r squared. And we know that it says the rate of the radius increasing, so dr dt is going to be 3 centimeters per minute. Now, unlike physics, where we have generally a specific label we want for SI, if this is what they give us, we're going to keep that, we're not going to change it. Okay, and we know that R in part A, and that's all we're doing is part A, is 6 centimeters. I'll leave you up to the challenge of putting a 24-meter calculator on your own. It is really challenging. Okay, so we need to find the rate of change of the area. So, here we got, nothing fancy, we don't have to do any more writing with this. So dA over dt equals pi, and that's not adding, so it stays in there, it goes out in front. And then the derivative of this, 2r, and that's 1 now for an exponent, dr dt. Okay? Oh, that's a pretty simple problem. Rather nice. A lot different from 13. So, you just go ahead and plug this stuff in. Pi times, this becomes 6. Well, let's just put 2 times 3 in there. So you know, understand where all that comes from. 2, times 6 is the radius, my bad, times dr dt, which is going to be 3 centimeters per second. Okay? Now, if we go ahead and multiply all that garbage through, if you leave it in pi form, it's 2 times 6 is 12, 12 times 3 is 36 pi centimeters squared per second, which makes sense. The area is changing, so the centimeters should be squared. If you went ahead and multiplied this out, which is fine, you can do that. I believe that's 113 centimeters squared, and that's not second, that's minute. So let's fix that. That's the physics teacher we coming out. On 13 centimeters squared per minute. Okay? All right. The last one we're going to do is number 19. And I'll read number 19 here together. We're told here a spherical balloon is inflated with gas at the rate of 800 centimeters per minute. So, cubic centimeters per minute. So, that sounds like dV dt is equal to 800 cc's per minute. Okay? Then it says, how fast is the radius of the balloon increasing at the instant in which the radius is 30 centimeters? Okay, so we're trying to find dr dt is that's the unknown that we're trying to find out. And the radius that we're looking at here at this particular moment in time is 6 inches, or sorry, 24, wrong problem, 19, 37. Okay. Now they didn't give us the formula here. Well, this is a sphere, that's kind of important. Okay, so how do we find the volume of a sphere? Well, this is one of those formulas you should know. If you're never sure, you can always look it up online. All that information's out there. But particularly if you're in Scholastic, hopefully you remember this. This is 4/3 pi r cubed. That's the form we're going to use And that means we're going to have to derive this, making the dV/dt W800 is going to plug right there. So let's go ahead and do that right now. Let's take the derivative of that, dV dt. These are both constants, but they're multiplying, so they'll come out like so. And then the derivative of r cubed is going to be 2, no, I keep doing it, 3r squared dr dt. Now, the nice thing about this here is the 3 cancels out right here. So this is going to give us dV over dt equals 4 pi r squared dr dt. Now, those of you who may be familiar with a little bit of geometry understand that when we derive this like that, we just got ourselves the surface area of the balloon, or surface area of the sphere. Okay, now we plug in stuff to see what happens. This is 800. Right, 800 cubic centimeters per minute equals 4 pi times, and that's the missing dr. I'm sorry, r squared is 30 centimeters squared. And then we're trying to find dr dt. So now we just got mathematics to do. So to get dr dt by itself, I'm going to divide both sides by this entire structure right here. So I'll put that down here, cancel that out right there, and put in parentheses 4 pi times 30 centimeters quantity squared. With a centimeter squared, we're going to cancel out with the cubic centimeters and centimeters up here, which is what we want. So dr dt, if you calculate this out, is going to give you, well, this is 3,600 for this. So this is 3,600 pi. And I'm going to leave it pi. The zeros cancel out, and 8 over 36 is 2 9, so this is 2 over 9 pi centimeters per minute. And there you have it. All right. Your practice problems on page 154. I'm going to give you 4 of them. 14, 18A, 20, and 22. Okay? Good luck.